Hello all. So now I'm going to explain about the project library management system using Terraform and AWS. As you know, that AWS is nothing but Amazon Web Service, which is a cloud service provided by the Amazon. And the advantage of cloud is you very much know that you can pay whatever you use, so that it can reduce our costs, and it has many more advantages, like you can use it anywhere from any system. And let's come to the Terraform, which is a new topic now. What is Terraform? Terraform is nothing but Terraform is an infrastructure as a code tool that lets you build, change, and version cloud safely and efficiently. It allows you to define cloud resources in human readable configuration files that you can version, reuse, and share. And let's talk about the advantages of the Terraform first. And as you know, infrastructure as code. So for example, let us take we are building something, some APIs have Lambda functions in AWS. We can do it manually, like create an API. We can give it a name and create a Lambda function. We can create a name. But when we created the whole infrastructure and some error occurs and you don't know where it has been occurred because you have did everything manually. So when you have infrastructure as code, nothing but your infrastructure as code using Terraform, and you will get to know that where is error is being getting triggered, so that you can go there, you can change the required changes, and you can solve the error. That is the main thing. And another advantage is reduce the development cost, as you can develop only whatever you want and you can deploy them. So these are the main advantages. So I'll show you how the code is being coded for the library management system using Terraform. And here it is. You can see I will show the folder structure once what I have followed. This is the main folder, library management system. And in that we have two folders mainly, SRC, and in SRC I have Python. And in Python, all the required Python files are being written. Mostly why we can use like other languages like Node.js and some other languages for coding. But yeah, we have used Python here, and also we have Terraform files here, and I will show you everything, each and everything. So let us go to the Terraform files, and first we are giving the providers nothing but the access key, secret key, and region. First of all, to do this project, you need an AWS account, and don't bother about it. Like you can use a free tier account so that there will be no billing mostly. But whether if you use an EC2 instance or RDS, there will be our S3 bucket. Sometimes a less bill will be occurred. So no issues. You can have a separate account with that. So you have the secret key, access key, and region. Region, whatever the region you want to develop your code, you can use that region. And access key. I'll show where I have declared these, and you can see the variables.tf file. And we mentioned .tf for all the Terraform files. And you can see like variable access key. I have configured here as a variable because I can use in the entire folder, I can use this access key wherever I want. So declaring multiple times in each and every file is not good, or it is very hard to maintain too. So here I have declared as a variable so that I can use it as where.secret key or where.access key. And these were access key, secret keys, and everything you can get from your AWS account. In settings, you can find them. And what is this module category module, and source I have given is .api. You can see that API folder in this, so that I can read all the files in this API. Whenever I run Terraform, I can see all this. So, okay, let us go to what is in the API folder. In API folder, first of all, we can see LMS API gateway. Nothing but I configured according to my project. LMS means a library management system API gateway. So first I have declared my API using a resource AWS API gateway REST API. This is what we use for creating an API. So this is the name reference name. You can create your own name, but create they should be unique. Again, for another resource gateway resource, I have used another name. You cannot use the same resource names for different resources. So it must be unique, but you can create your own names, which is familiar to you. And name. What is the name? You can declare a name for your API and description and tags. Tags is optional. And what is this resource? API, AWS API gateway resource. And you know that in AWS, you can find uh, parent resource or root resource, which will be predefined. So under this resource, we are creating some more resources, sub resources, you can say it, and give it as a path as V1. Under that slash, we will be having V1. Under V1, we will be having this library, and we will go to another one now. So we have now created an API. So after creating an API, we will be creating the methods. So I will show you the one method once. Lambda get author method. So before while creating method, we use the resource AWS. First, we created the get author resource. Under that get author resource, we will be creating a method like get author method. So resource AWS API gateway resource, and the reference name is get author. And REST API is nothing but AWS API gateway REST API dot bsk terraform dot id. This is the REST API ID and parent ID. Nothing but under library we are creating this resource, right? So the parent ID will be the library bsk, and the path party's name will be displayed there. And now the method creation. Under the get author resource, we'll be creating a method called get author method. And the method is resource AWS gateway method. Here you can see the difference, like for resources, we will be using AWS API gateway resource. And for method, you can see AWS API gateway method. So these will be differentiating for each and every resource. For Lambda functions, it will be different. For S3 buckets, they will be different the same way. And this is a get author method. And REST API ID, the same thing we used here. And resource ID, under which resource we are going to use it, like get author resource, right? So we are using the reference name, not the path part. You can see the difference, right? Get author, here we have the underscore, and here we have the slash. So we used, whenever we want to use a resource, we use it by its reference name. It's nothing but like calling a function in some codes. And what type of method is this? Get an authorization. Yes. Here we use the authorization to validate the user in our library management system. For that, we have an authorizer in AWS, and I will show you how it works. First, you will be having an IAM role, and we can define it as manually in your AWS account. Now, first I will show you the code. Resource, you can see the resource like API gateway authorizer and type request. And what and all the identity resources you are going to validate here. One is the header.email. I mean, we will be passing the email and password in the headers. I'll show you later. And you can see that name, your wish, and that it can be whatever you want. Authorize a resource in my code. REST API ID, you know that we are using that in every part of the code. Authorizer URL. This will be like uh, AWS author lambda function. Authorizer lambda is nothing but my lambda name. I will be invoking that. I will show you that lambda again. Uh, authorizer lambda. You can see it here. And another advantage is that you can see that in any code, if you are using the reference of a particular function or anything, before that you have to declare it. But here it is not like that. You can declare it anywhere of any part of the code so that you can use it anywhere. That is the another big advantage is in the Terraform and authorizer credentials. Nothing but we'll be giving our uh, IAM role dot ARN and after this we'll be declaring our lambda function, and this is our lambda function. In this is the same way we create all the lambda functions, and the resource name is AWS lambda function. This is our reference name. S3 bucket. Why we are using S3 bucket is we are storing all our codes in the S3 bucket, and also while uploading for every lambda function, we will be attaching a Python code, Python file. In that only we will be writing our logics. So, but we cannot directly attach it. We have to zip it and attach it. For suppose, let us consider you have to change a Python, or you have to change your logic in Python code, but you have already uploaded the Python zip file to a lambda function. So what you can do now, you cannot rewrite the code again and delete again. You delete again and attach the new file again. So that will be taking a more time. So to reduce that, we will be using third-party modules. Here you can see the modules which I have got from the GitHub. By using them, I will be importing those modules, and I will be zipping the files which we can call as dynamic zipping. What it does is whenever you change a code, you change your Python logic, which is being attached to the Lambda function. Uh, Whenever you run your Terraform, it will check for any changes so that if any changes occur in your Python logic, it will automatically detects and it automatically changes the code and uploads in the S3 bucket so that you can access it from the S3 bucket directly. So that is why we are using the S3 bucket and S3 key. Module.authorizer.s3 object.key, nothing. And function name, you have to declare a function name for your lambda function. It can be anything. And memory size timeout, they can be given others like 512 also you can give, 60 seconds also you can give, same way. And role is nothing but the IAM role we have declared here. The reference name academy lambda access dot ARM. And handler. Handler is nothing but the function in your Python logic, and runtime here we are using Python 3.9, which is supported by the AWS currently. You can use 3.7 as well, issues with that. And depends on what is this. When you write depends on, first this will be executed. That means module.authorizer zip. What is this authorizer? This one. First, the lambda function will be taken. The Python codes will be taken. I have given the path. You can see in SRC Python, I have the authorizer. SRC Python, I have the authorizer. In that, the authorizer file will be taken. It will be zipped and it will be attached to the lambda. Similar way, the models. You can see the models. The entire model folder will be attached. So, and also service. I will show those codes later. Now we'll discuss the Terraform codes and the environment variables. These tags are you can these are optional basically, but you can have it to show that the owner, the project name, the runtime, changes in time. Now layers. I will discuss the layers first. What is these layers? What are these layers? Layers are nothing but in AWS you have a service like Lambda layers. So that suppose you are using this Python or you are using some SQL Alchemy or any other things. Here we are in SQL Alchemy, AWS ICOP G2. So you're using it, but uh, The AWS will not consist of these things, these modules or these packages. So that you have to upload these packages by zipping them. So you have a service called Lambda layers, so that you just include them in some one text file like requirements.txt file, and you just include them in the Lambda layers. That's it. I will show the Lambda layers code. Yes, module Lambda layer and source. Source is nothing but the module Terraform AWS. This is third-party module that we are using here for dynamic zipping, and we are giving the runtime. We are giving S3 bucket variable also, and artifacts directory is nothing but the in this way it will be stored in S3 bucket. It will be stored as Academy 22, and under that is a folder Shashi. Under that is a folder called Lambda layer. In those Lambda layers, these will be uploaded. So the source path is we have to give the path like requirements.txt. So this is how we declare a Lambda layer. We'll come back to the Lambda authorizer ID. VPC configurations. Uh, VPC or nothing, but you'll be creating an ODS. And for that ODS instance, you'll be having the security groups and subnet IDs. We'll be declaring them in the variables, and we use wherever we required. As I have shown the access key, secret key, the same way we'll be storing them in the variables.tf file like this, subnet ID security groups, and we use them wherever they are required. Now tags are optional. Environment variables. In environment variables, actually every Python code here is will be using the SQL. We'll be using SQL. So for connecting the SQL, we need everything like post. First of all, here we using the PostgreSQL, and for connecting it to the AWS, we will be using the host. We will be having the user, password, database name, port number, timeout, and schema. First, these are stored in the variables. I will show them. First, the host. The host will be, this will be like, it will be there in the RDS section in the AWS. Username will be Postgres. You should have a PG. You should download this PostgreSQL for using this database, and port number and password, database, timeout 15 seconds. After trying for 15 seconds, it will be showing an error like timed out, and S3 bucket. As you know, like in S3 bucket, we are storing everything. Come back to the same Lambda function and environment variables. And Lambda permission, we need a Lambda permission for all the Lambda functions we are using. And here, the main thing is like AWS Lambda function, authorizer Lambda, your Lambda reference name, this is, and dot function name. This is how we declared function name, and source ARM. Source ARM will be nothing but your API gateway, BSK Terraform dot execution ARM, and authorizer resource dot ID. This is how we declare a Lambda function, including a method. The same way we use everything. And I'll show you the method responses and integration responses now. This is how we declare the method response. Suppose you are running a Lambda function and everything is good. You will be getting something like everything good, hello world. Suppose assume as hello world program. You are printing hello world. So it will be printed as hello world with a status code for 200. The 200 stands for it is successful. The program is successful without any errors. So the status code will be defined by ourselves. And this is how I declare REST API ID. Resource ID is nothing but the resource, get author resource, and HTTP method. Which method it is? Get author method dot HTTP method. Status code you have to declare it as 200 in string. And response models we are keeping empty here. And resource. What this is integration response. This is method response. Integration response is nothing but whenever you are getting the 200 response, you can define the way of output like you can define the output like whatever the way you want. So for that, we are be using the integration response, or you can raise the status codes by using the integration response as well. The same thing we use REST API ID, resource ID, STP, and status code. This will be like AWS API gateway method response, and get order 200 error will be the your reference name for 200 response and dot status code selection pattern. For 200 response, mostly we use this selection pattern, which will be like empty thing. And let us go to the 400. Here we will be using like invalid request. Suppose your code is raising invalid request, you need to raise a 400 response. So for that, we will be giving a selection pattern. If this string is considered is there in the error thrown by the lambda function, then automatically it will invoke the 400 status code. This is the way it works. And if your error consists of this string, it will be raising a 404 error. This way it works. And this is how all the lambda functions are declared. So every lambda function will be similar, just the names will be changed. And deployment. After declaring everything uh, in your account, like in your AWS account, like APIs, Lambda functions, and all. Let us, before going to the API deployment, let us go to the Python folders. Here we use Python for writing our code logics or Lambda logics. And for authorizer, we can see that from service.db init, I'm using init importing the DB. I'll show that from service.db I'm importing the class DB. Here I'm not doing nothing, but I'm just connecting my database to the Lambda function. You can see that I have declared everything like user, password, host, database, name, timeout, schema in my environment variables. This is the way you can import the environment variables. First, you have to import the OS and OS.environ user. And here you can see that from SQL Alchemy import create engine. What is this SQL Alchemy? SQL Alchemy is a popular SQL toolkit, and it is also an object relational mapper. The advantage of using SQL Alchemy is you can write it in Python so that you can use database full-fledged, like it will use full flexibility to the user so that you can use every part of the SQL using Python. So again, you don't need to implement it in the SQL. So that will be a very big advantage for the Python developers. And here I'm storing them in the user password like that. And in this function, I'm first formatting these strings like using PostgreSQL. In this place, the user will be attached here and the password will be here the same way. It will be like user password and host. This is the way it will be. And the create engine is used to connect the database. Here we are giving the variable as DB string, which is nothing but how we formatted the string. And timeout you have given also also given the timeout and also schema. And we are returning the session so that we can call this class wherever required. So in authorizer.py, I'm connecting database so that I'm using this. And what is this models.users? You can see in models in this users.py in the class users, you can see now the table name I have declared as users and the email, the column. What is this type, data type? This is primary key or not. Nullable, it can be false. It means it is mandatory, right? Like the password is admin. Is admin will be a boolean. If is admin is true, the user is admin. If user admin is false, the user is just a normal user. We will be validating these three things from the database in the authorizer. And if you go to the authorizer, and I am connecting the database, and from a template, what in the template we are importing these email, password, and method ARN. Method ARN will be predefined for the authorizers in AWS. And now running the query session dot query users. Users is nothing but my users table. Running this table, what is this filter? Like, for example, in SQL, you will be typing like select star from users where username like that. Filters is used for like where condition. Users dot email equals to email. I'm checking it from users dot in users table email is saved to this email or not and password. And if the admin is true, I'm giving effect is equal to hello. Else, but even though the credentials are correct, but admin is false, so we'll be allowing only for get method. So if get in method ARN, we'll be allowing. Otherwise, we'll be giving deny. This is the way we give the authorizer. The same way for all the lambda functions, it will be same. Like importing and connecting and everything will be same. Now this is the way you create. You will attach the. You will be writing the logics and you will be attaching them by zipping. Here we will be zipping using this module, third party module, and later we'll be attaching it here. Anyways, we are giving it here, and you can see the handler. Handler, you will get all the details. Dot lambda handler. Here we are attaching our Python files. Now I'll show you the deployment. What is this deployment? So that here our infrastructure is ready, the codes are ready, the lambda functions are ready, everything is ready. That means your backend application is ready. So you can test it or you can pass it for the front end development, everything. But how can we use this? Like we need to deploy this before using this. So for deploying, we are having a resource called AWS API Gateway Deployment, and we'll be giving the REST API ID, lifecycle variables, and also we'll be having the stage usage plan and main. Uh, Not specially mentioned, not specially required. All this the deployment is nice, and I'll show you how it works though. I'll log into my account and I'll show you how it works. Mm, I'll show you how API gateways are created, how Lambda functions are created, and I'll open this API gateway in a new tab. You can see this is the library management system API. I'll open this. In this, you can see the resources. First, we created a V1 resource under that library. Under that, we have created all the resource like address resource, author, category, get address, get author, all these resources we have created. And also we have created an API key, which can be seen here, XAPI key. If you click on the show, you will get to know your XAPI key and the authorizer. We have created an authorizer too. You can see this is our authorizer. And in the resource, if you open this post, you can see this how we have created all this like method responses, integration response, and what are the headers. And you can see this link which will open the lambda function attached to this post method. If you click on this, this is the lambda function, and this is the way we attach the lambda function to the API. And you can see that we have imported all the required modules. Also, after deployment, the stages will be created under the stages. If you want to use this library address, you can use this URL. And as a backend developer, we will be using the Postman tool here. And I will open that Postman tool too. And this is how the Postman tool looks like. And I will show you the get author. And you can see here that I have declared this variable email, password. I have given this. These are present in my database. XAPI key. This is some random XAPI key. I have already declared this as another variable. And parameters, you will be giving the author ID. It will be an email ID. It will be like a 16-bit thing so that it will be more secured. And now the authorizer validates the email first, and then the password, and then the XAPI key. Suppose if the email is wrong, we will be sending the request. It is like unauthorized with a 401 response. Suppose if the email is correct and the password is also correct here, and also it is an admin. So you will get to know the details of the author, like author ID and the address of that particular author, what is his specializations, and author name, and everything you can get to know. Suppose if the password is wrong, you will be getting the same message like unauthorized. Consider it as except in case some random values I give, we'll be getting like forbidden. Like XAPI is also very mandatory for us. Can if author ID, you'll be sending the author ID which is present in the database. If you send some random values here, invalid request, missing or wrong details in the column author ID. Or if you're not sending this key at all, you'll be getting like missing required parameters like author ID is missing. Hope you understand. This is how a get method works. And let us consider this post address or post author. Yeah. The same way headers are given, and you will not be having any parameters as post method is used to create uh, create the new author here, or if you use the address, it is used to create the new address. Same way, um, you will be giving the details in the JSON body. For author, we'll be giving the address ID, the author name, everything in the JSON body. It validates the JSON body too. Suppose if the author age is 40, right? If I give like pixie or something, string, let me give an string. I'll send it. See, because author age it is an integer, but here we gave it a string. So every field or every part of the JSON body will be validated. So if I send it correctly, author created successfully, and the recently created author ID will be given here, so that you can use this author ID. I'll copy this and paste this in get author. So let us do this, and you can see this the new author what is we have created recently. And what is put method to it is used to update. So everything, even the author ID also will be giving JSON body itself. And if you want to change some author name, for previously it is Kiran, right? I will give something like LMS and I will send it. The author updated successfully. And I will copy this and paste this in get author again. I'll paste this. You can see that author name should be changed to LMS, right? Yeah, you can see this author name is LMS now. This is how output method works. It is used to update. Similarly, it works for category, address, library, every module. So this post method is basically used to test the backend APIs. This is how the project works, and we For front-end users, we'll be giving this entire JSON. They will be taking this entire JSON and they will use as they wish and as they want, and they will create the front ends. And they give the responses as they wish. And they will use it. And another thing is we are here everything like every output we are getting in JSON bodies, right? So why we are using this JSON body everywhere? It is like declaring anything in a JSON body, like we can access it easily. Like like in dictionary for this key, we will be having this output, right? Or this value. So in JSON body, we can have anything as input, so that anything has keys, anything has value, so that you can easy with ease. So this is why we are using JSON body here. Mm, this is how the code works. Thank you. Thank you for thank you for listening to my project. This is how my project works. Thank you.